Welcome back to Master Academy of Mathematics. This is the next continuation topic of multiple integrals. So till now we completed double integral and triple integral evaluation. Now I am going to take a most important topic in the double integral, change of variables into polar coordinates. So before entering into this particular problem, first I am focusing on the single integral. Do you have any idea that in the case of single integral, is there any chance of changing into another variables? The previous variable is nothing but x variable. When you are calculating the integrations, sometimes it is very difficult to find out its answer. In that case, you are changing into another variable, say it is t. So x variable you are changing into t variable. In that particular idea, there we are going to follow three important cases. One is the old variable is converting into new variable. Next is dx is converting into in terms of dt, that is the second task. Third task is nothing but for the new variable we need to identify the limits. That was did in the case of single integral. The same type of logic is also applicable in the case of a double integral. Here also we are going to use three important tasks. One is the old variables which are denoted here, it is x and y. They are converting into another variables. Suppose if you are converting into another variables in terms of some u and v. So that type of procedure you can convert into u and v. And second task is nothing but the same dx and dy values you are writing in terms of du and dv. Third task is nothing but you are identifying the new variables limits. These are the three important tasks in order to find out the change of variables. But the problem is, if it is converting into another type of variables, such type of procedure generally said to be Cartesian coordinates. That means again it is converting into another type of variables. We call it as Cartesian coordinates. Sometimes even if you convert into another variables, it is very difficult to calculate the double integral. In that case, instead of converting into another variables, you are converting into some trigonometric functions. So that type of process we call it as polar coordinates. So change of variables in the double integrations basically divided into Cartesian coordinates and trigonometric coordinates. Cartesian coordinates means it is converting into another two new variables. Now instead of using another variables, if you are converting into trigonometric variables, we call it as polar coordinates. Actually, when I draw a two-dimensional graph regarding to the double integration, generally this is x-axis and here it is y-axis. Generally it is taken as origin. If I am going to write a point in a two-dimensional graph, what is the meaning of point? This point I am just denoting with x comma y. That means from this point you just identify the distance from the x-axis, identify the distance from the y-axis. So this intersecting point is generally denoted by x comma y. The meaning of this is the distance from the origin to this particular value. It is only an x value. This x value I am just denoting with a small x. Similarly, this is nothing but the distance from the origin to y value. This value we suppose it as y. So these two values you are simply writing here within the brackets x comma y. These are indicating the distances from the corresponding axis. So generally this is said to be Cartesian type. But when you are coming to the trigonometric type, you are just writing here again two axes x and y, and this is your origin. I am just locating a point, here it is. Corresponding to that point, here you are converting into new variables. That new variables I am denoting with r and theta. So this point is denoted by r comma theta. Where r stands for, it is the radius, and theta is nothing but it is the angle between the radius and the x-axis. That means you just identify this is a radius from the origin. It is the distance from origin to this particular point. Generally it is denoted by r, which is nothing but radius. And immediately you are calculating the angle between the radius and the x-axis, that is generally denoted by theta. So in the case of change of variables into polar coordinates, our main intention is nothing but first you convert into r and theta. After get dx dy, it is represented in terms of r and theta. And third task is nothing but you are identifying the limits of r and theta based on your given problem. So that we will take by taking one small example. But before going to that, I just give you a procedure. The first step is nothing but in order to convert into polar coordinates, the x and y variables you are converting into r and theta by using a principle x equal to r cos theta and y equal to r sin theta. I am just giving you a standard procedure in changing into polar coordinates. And the second step is it is going to satisfy a condition x square plus y square is equal to r square. This is the first step. Coming to the next one, in the second step, the same dx dy, this can be calculated as r into dr d theta. Generally, to find out this dx dy, it should be calculated as Jacobian into dr d theta. Here Jacobian is nothing but r value. From that you can write down r into dr d theta. Third task is nothing but you are identifying the limits of r and theta based on your given original limits of x and y. So using that limits of x and y, you just identify the limits of r and theta and directly find out the integration part. So this is the brief procedure to convert the variables into polar coordinates and calculating the integral value. Now let us have a first problem. Evaluate double integral 0 to infinity and 0 to infinity e power minus of x square plus y square dx dy by changing into polar coordinates. So definitely they are going to mention this statement, changing into polar coordinates. So as I said, the previous old variables are x and y. Now we are converting into polar coordinates. In order to do that, as per your task number 1, you are just substituting x equal to r cos theta, y equal to r sin theta, such that what is the condition here? X square plus y square equal to r square. That is the condition. Now what is your next task? The next is dx equal to or dx dy equal to the directly r into dr d theta. This is your second task. Now third task is nothing but we need to identify the limits of new variables r and theta. But before going to that, you just think about the given variables. What they have given? Double integration. So there is no variables on those limits. So as per your condition, dx dy means, so it is function f of x comma y that is also equal to f of y comma x. So order of the integration has no importance. Either you suppose first is x integral, second one is x integral. So I am just supposing first integral is x, 0 to infinity, and second integral is y, it is 0 to infinity. Now using this particular limits, now we are going to calculate the limits of new variables. In order to identify the limits of new variables, just you substitute first lower limits of x and y. If I am substituting x equal to 0 in your polar coordinates equation, x equal to 0, 0 equal to r cos theta, it is looking like a into b equal to 0. Either this is 0 or this is 0. Generally, r is radius never be equal to 0. So it is cos theta equal to 0. From this, theta equal to, for which theta value you are getting cos is 0? It is generally said to be pi by 2. Similarly, you substitute the next lower limit of y variable, y equal to 0 in the second equation, 0 equal to, if I write there, r sin theta. So from this, r is not equal to 0, sin theta is equal to 0. From this, theta equal to 0 only. So we have now theta limits 0 to pi by 2. One variable is over. Now we need to calculate r limits. In order to r limits, you just consider the equation x square plus y square equal to r square. In this equation, you are substituting the limits of x and y. Limits of x and y means substitute first lower limits of x and y, 0 and 0. So if I write 0 and 0, what will be the r square value? 0 only. Similarly, if I substitute upper limits of x and y, infinity square, you will get infinity only. Or one lower limit, one upper limit. What will be the answer? Infinity. So from that, based on limits of x and y, you are getting r limits are nothing but 0 to infinity. Is it not? So r limits and theta limits are over. Now you are calculating your given double integration 0 to infinity, and here it is 0 to infinity e power minus of x square plus y square. It is of dx dy. This is equal to, you need to write down the new variables. So r limits, it is 0 to infinity, and theta limits 0 to pi by 2. In your expression, e power minus of, what about this x square plus y square value? It is nothing but r square. What about dx dy? It is r into dr d theta. Okay. Now here the thing is, first integral you are keeping as it is 0 to infinity. Integrate with respect to theta first. So theta means e power minus r square into r, it is constant. Nothing is there means 1. Integral of 1 is nothing but theta. The theta limits 0 to pi by 2. Still we have here it is dr. So it is integral r equal to 0 to infinity e power minus r square into r. Substitute your upper limit pi by 2. So that pi by 2, it is a constant term you are taking out of the integral, and we have only dr. So to do this simplification, you just suppose that r square is equal to some t. You are changing into another variables. So it is 2r dr is equal to dt. So that value I am substituting here. This is equal to pi by 2. So that I can write r limits. Previously it is r limits. Now it is changing into new variable t. R equal to 0. There t equal to 0. R equal to infinity, t is also equal to infinity. E power minus r square means e power minus t. R dr, as per your changing into variables, r dr is nothing but dt by 2. So directly that 2 constant, it is pi by 4. Integral of e power minus t is minus e power minus t. The t limits 0 to infinity. So it is pi by 4. Substituting your upper limit, minus e power minus infinity value is always equal to 0, and minus of means plus t equal to 0, it is 1. So final answer is nothing but it is pi by 4. This is your calculation of double integral by changing into polar coordinates. Now let us have another problem. Double integral 0 to a and 0 to under root of a square minus x square y into root of x square plus y square dx dy. So we need to find out that integral value by changing into polar coordinates. So as usual, first thing is nothing but you just write down that x and y variables in terms of polar coordinates. Same procedure. I am just writing x equal to r cos theta, y equal to r sin theta, such that the condition is x square plus y square equal to r square. That is the first task. The next is you are changing that dx dy in terms of dr d theta. It is r into dr d theta. These two are very simple to substitute here, but only the thing is identification of the limits of the new variables is important. But before going to that, you just consider your given limits. What about your given limits? 0 to a is there, 0 to root of a square minus x square. One of the integration limits consisting of variable x. So automatically these are belonging to y limits. So automatically first integral is x integral. So x limits 0 to a and y limits are nothing but 0 to under root of a square minus x square. They have given. Okay. Now using that, I am just entering into the limits. Limits means first you focus on only lower limits. If I write x equal to 0 in your polar coordinate equation, r, that is 0 equal to r cos theta. So from that directly you are getting theta equal to pi by 2. Similarly, If I write the next lower limit y equal to 0 in the second equation, 0 equal to r sin theta, from this theta equal to 0. From these two, you can say that theta limits are 0 to pi by 2. So one variable limits over. Now in order to enter into r limits, you consider the equation x square plus y square equal to r square. Substitute the limits of x and y. Here I am substituting both first lower limits. Then what will be the answer? 0 plus 0 is nothing but r value 0. Coming to the upper limits, x value a and y value root of a square minus x square. When x value is a, here if you substitute that, a square minus x square is nothing but that y value is 0. So x value a, y value 0. Finally you are getting r value is nothing but a. Similarly, one lower limit, one upper limit. Here also you are getting. So based on the limits of x and y, you are getting the r limits are nothing but 0 to a. So once you know both the limits, now you are entering into double integral 0 to a, 0 to under root of a square minus x square of y into root of x square plus y square of dx dy. This is equal to, write down r limits 0 to a, next theta limits 0 to pi by 2. Coming to y, y means it is r sin theta, and under root of x square plus y square is nothing but r square. What about dx dy? R dr d theta. First you do the simplification. So here r limits 0 to a, theta limits 0 to pi by 2. That root of r square is nothing but r. So totally r cube, and it is of only sin theta dr d theta. So thing is, first integral keeping as it is, integration with respect to theta means r cube constant, sin theta integration minus cos theta, theta limits 0 to pi by 2, and still we have here it is dr. So it is r equal to 0 to a, it is r cube. Substitute your upper limit. What is cos pi by 2 value? It is automatically 0. And minus of, means here already minus is there, plus theta equal to 0. Cos 0 value is 1. So we have here it is dr. Now this is equal to your simplification, r equal to 0 to a. 0 plus 1 is nothing but 1 only. So we have here it is r cube dr. What is integral of r cube? R power 4 by 4. R limits 0 to a. So finally you are getting a power 4 divided by 4, and the lower limit is 0. So this is your final answer of a given integration by changing into polar coordinates. Now let us have another different type of important problem. Double integral 0 to 1 x to root of 2 minus x square, x divided by x square plus y square dy dx. Now this problem you need to evaluate by changing into polar coordinates. So same procedure again, the old variables you are converting into new. That means let x equal to r cos theta and y equal to r sin theta, such that what is the condition? X square plus y square equal to r square. First task. The next is you are just writing dx dy in terms of r dr d theta, right? Two tasks is very important, easy, and finally we completed 2-1. Now the problem is we need to identify the limits of r and theta. Before going to that, you just look at the limits of your old variables. First integral 0 to 1, second integral x to root of 2 minus x square. So automatically you can say that x variable is there, means definitely y limits, and this is your x limits. So your x limits 0 to 1 and y limits are nothing but x to root of 2 minus x square. Okay. Now using that, now I am entering into limits. You just think about the lower limits here. Previous in the two problems, the lower limits are nothing but real numbers. But here x equal to 0 is one real number, whereas y equal to x is there. So in that case, before getting that particular value, first you focus on r value. Once you get r value, you can easily find out the theta values. In order to enter into r value, look at the equations here it is. One is y equal to x and another is y equal to this value. Here I am just supposing that value y is equal to root of 2 minus x square. Squaring on both the sides, y square equal to 2 minus x square, or I can write it is nothing but x square plus y square is equal to 2. This 2 I can write it as root 2 whole square. Okay, so it is looking like x square plus y square equal to r square type. So clearly you can say that r limits are nothing but only in the positive quadrant, only in the positive side. 0 to that maximum r value is nothing but 2, root 2. So once you get the r value, now you are entering into the theta limits. In order to get that theta limits, again the same procedure. First you suppose lower limit x equal to 0. That value is substituted here. 0 equal to r cos theta. So from this, either this is 0 or this is 0. This never be equal to 0. So cos theta equal to 0 means theta value becomes pi by 2. Okay. Coming to the next step. There is no lower limit at all, but I am substituting here the next lower limit. Y is equal to, what is the lower limit here? It is x, the next lower limit. Now that value is substituted in your second equation. The second equation is this. So x equal to that r sin theta. So that I am writing r sin theta as it is, here it is. Now the problem is only sin theta equal to, it is nothing but x by r. So this is equal to x divided by, what is r value? Root 2. But we don't know the value of that x value. Is there any possibility of x value other than this x equal to 0? Other than x equal to 0, we have another possibility, is there 1. So that 1 value I am substituting here, 1 by root 2. So sin theta equal to 1 by root 2. Then what about the theta value there? That theta becomes pi by 4, is it not? So finally you are getting the answer. Theta limits are, it is, we have a rule pi by 2 and pi by 4. In that the lower value is nothing but pi by 4 to, here it is pi by 2. So once you get theta limits, now you are entering into the integration 0 to 1. It is x to root of 2 minus x square. It is x divided by x square plus y square of dx dy. Now this is equal to r limits 0 to root 2 and theta limits, it is pi by 4 to pi by 2, and substituting the value, x means it is r cos theta divided by x square plus y square is nothing but r square, dx dy is r dr d theta. Okay, so r into r square, and this r square is cancelled. You will be having here only cos theta. So r equal to 0 to root 2, first you keep as it is. Integration with respect to theta, cos theta integration is sin theta. The limits here it is theta pi by 4 to pi by 2, and still we have here it is dr. So r equal to 0 to root 2, substitute your upper limit. What about sin pi by 2 value? It is 1 minus sin pi by 4, it is 1 by root 2. So this is of dr. So that 1 minus 1 by root 2, it is a constant term, and the integral of nothing is there means 1. Integral of 1 is nothing but r. The r limits here it is 0 to root 2. So finally you are getting the answer 1 minus 1 by root 2. Substitute your upper limit root 2 and the lower limit is 0. That is your final answer. On making the simplification, it becomes root 2 and minus 1. That is the integration of your given double integral by changing into polar coordinates. So let us have one problem. I give you this as exercise. So I just give you clue also. Evaluate double integral x square y square by x square plus y square of dx dy between x square plus y square equal to a square and x square plus y square equal to b square, where b is greater than a, by changing into polar coordinates. Only the thing is, first two tasks are very important. X, y converted into r and theta, dx dy can be taken as r dr d theta. Problem is only the limits. Look at the problem. X square plus y square equal to a square, x square plus y square equal to b square. Clearly, in the place of r square, we are having a square and b square. So you can say that r limits are nothing but a to b, lower limit to upper limit. Similarly, in order to calculate your theta values, we need to write down the lower limits, but there are no lower limits at all in your given equations or given problem. So look at that particular equations. Are they representing circles? Yes, both are representing the circles. What about the circle angle? The circle angle is nothing but it is 0 to 2 pi. So we know that theta and r limits, and directly substitute there, and just you do the simplification. So final answer I am just giving you the answer, pi divided by 16, it is b power 4 minus a power 4. This is the final answer of your given double integration by changing into polar coordinates. You just find out its final answer. So with this, changing the variables into polar coordinates topic is closed. So in the next video session, we enter into change of order of integration in the double integrals. So that is very important in the examination point of view. Have a good day.